In today's super challenge, we'll be working with functions with parameters. A parameter is an extra piece of information that you pass to the function to customize it for a specific need. Log into your code.org account and check for your username in the upper right. Make sure to read the instructions and look at all but the last hint if you need them. Return to this video if you need more guidance. You can pause this video and begin on your own now. Puzzle 1. This video is to help those who need extra explanation. So instead of jumping right into using any for loops or functions, I'm going to just write out the whole long sequence so that we can find the patterns in the sequence. Now that I have the sequence, let's try to match up some stacks. don't see a pattern for these 1, 3, and 4. So I'm going to break these up so that there's only one at the top to match this one. That's better. Now it seems we're going to repeat this sequence, but each time these variables are going to change. So that calls for a for loop. I also noticed that we're moving backward and turning left twice, so let's simplify that with a repeat and save a block. This should work, and already uses a small amount of blocks. But since this is supposed to be a function challenge, let's try to decide what might be the most usable function that we could apply to future situations. Maybe the moving up and over to get the honey and then back down. Essentially this blue chunk here. We can call it get honey. Whoops, this should be a 1. Great work. Continue on to the next puzzle on your own. Pause here. Puzzle 2. First, I'm going to decompose this and just look at the numbers. 3, 9, 12, 21. These are all multiples of 3. But if I count by 3s, we have 3 down here, we don't have a 6 up here. We have a 9 in the next column and a 12 in the next column, but no 15 here or 18 here, and then we have 21 at the end. So it seems like we're going by 3s, but we don't always have something to collect. I also noticed that there is a slight zigzag pattern going on, so I might start with a forward right, forward left as a base for this. We could put this in a repeat 7 times, but since we know that the number of nectars is predictably variable, let's use a for loop as our repeat. Start with 3, go to 21, and count by 3. Now, sometimes we need to veer off our path to collect nectar. Sometimes it's to the right, and sometimes it's to the left. So, if we make a function for this, we probably want a parameter for the direction that the function should go. The amount for getting nectar will also be variable, so we'll need a parameter that puts our counter in so that it doesn't do the same amount every time. Excellent. Go on to the next puzzle on your own. Pause now. Puzzle 3. Use the suggested functions to draw 4 rows of hexagons. Notice how our even number rows are shifted to the right. Let's try making the draw a hexagon function first, because that's straightforward. Breaking this problem into parts is an example of decomposition. So a hexagon has how many sides? Good. I don't know how much to move forward, so we'll use some trial and error. Our turn right should be whatever 360 degrees divided by 6 corners is, which is 60 degrees. Good. Now let's figure out how to do a line of 3 hexagons. 1, 2, 3. How would we jump from here to the next hexagon in line? To get situated for our next row, we need to get from here over to here. We are shifting down and forward, I guess. We know these jumps are 120 pixels and that these sides of a hexagon are 40. So use your knowledge of 120s and 40s to get back over to here. Then turn right 60 degrees, forward 40 pixels, and then left 60 degrees to get set up for the next row. When we're done doing a second row and move to shift backwards to this third row, we need to go from here to here. Use your 120s and 40s again to get us back to here. Then turn right 60 degrees, forward 40, turn left 60. Now that we have our 4 functions, let's put them together. Great job! Move on to the next puzzles. Pause here. Puzzle 4. Okay, I see a pattern made out of octagons. I know we're supposed to use functions, and the instructions recommend parameters of some kind. Let's start off by making a simpler function for just a single octagon. Now we need to make a jump in between octagons. Close, but I see a little gray peeking out. Let's make a function for a line of octagons like our last puzzle. Only this time the number of octagons are different in each row, so we need a parameter to say whether there should be 2 or 3 octagons. If we do 136 plus 136, we get, and that brings us to here. Then if we turn left 45, jump back 40, turn left 45, jump back 40, turn right 90, and jump back 40, we end up here. We're probably using too many blocks for this. We can try to shorten this later. Since we're going to be jumping back to start rows over and over again, it would be helpful to do this in a function instead. pretty good to me, but I'm guessing we need to improve our jump back function. Let's see if the hints give us a clue. Yay, that fixed it. Go on to the last puzzle on your own. Pause now. Puzzle 5. Yeah, I'm pretty sure I can't begin to figure out what's going on here. I'm going to look at a few hints to help me. Shucks, I'm never great at thinking about the color changing. It starts off very blue, but becomes less blue over time. The red starts off small and gets bigger as the counter gets smaller. Subtraction, maybe? I don't know what's going on with the green. I'm going to use the last hint.